degrees. Measure them and you'll see. Adjacent angles add up to be 180 degrees. I am a parallelogram. I am a parallelogram. My four sides are straight, but the angles at the corners they make aren't always 90 degrees. Measure them and you'll see. I am a parallelogram. I am a parallelogram.
I totally hope you guys have that song stuck in your head the rest of the entire day, because that would make my day so awesome. Alright guys, good morning, or good day to you. We have today, of course, properties of parallelograms, and what better way to start that off than a rockin' awesome, theme song for them. So, what exactly are parallelograms? Well, let's see. Are there special kinds of quadrilaterals? What we're going to find out is, and what many of you already know, there certainly are. Okay, you're not going to have just quadrilaterals, you have specific types. So, a polygon that has four sides is classified as a quadrilateral. That's your blanket family type. There are many different types of quadrilaterals that each contain distinct specifications to exist. List all different kinds of quadrilaterals you can think you get up below. So just think of a few you have right here, like, squares, rectangles, diamonds, rhombuses, okay, so on and so forth. Today, we're going to focus on just the parallelogram, okay? It's any quadrilateral that has both pairs of opposite sides parallel. So the important thing, like the number one distinct thing about this, if you have a four-sided shape where opposite sides are both parallel, boom, parallelogram, okay? Parallelograms also have unique properties that fall from its characteristics. So here's a theorem. If a quadrilateral is a parallelogram, then its opposite sides are congruent. On top of the opposite sides being parallel, we also know that opposite sides are going to be the same. Okay, congruent. They got to be exactly the same. So this is 5, this is 5, this is 7, this is 7. Okay? Easy as can be. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Now, opposite sides are easy. Okay? Easy to see. Opposite angles, if I have an angle right here, the opposite angle is diagonally across from it. So it's not the adjacent ones, but across from. Okay? So if I call this A, B, C, D, I can say that angle A is congruent to angle C. Then I can say that angle B is congruent to angle D. Alright? That's all we're looking at there. Finally, if a quadrilateral is a parallelogram, its consecutive angles are supplementary. So I'm going to go ahead and label this A, B, C, D again. And you saw us in your parallelogram song, which is, I am a parallelogram. Yep, that's right. Welcome that song back in your head. All this says is that angle A, the measure of angle A plus the measure of angle B equals 180, because they are adjacent to each other. But guess what? I have a few pairs of these. Measure of angle B plus the measure of angle C equals 180 degrees. Boom, boom. Ah, I got a few more. Measure of angle C plus measure of angle D equals 180 degrees. Ah, guess what? One more. Measure of angle D plus measure of angle A equals 180 degrees. So it's just any angles directly next to each other at the 180 and angles across from one another are congruent. That's the gist of all of this for parallelograms. Those are your big ideas. Okay, so you get those under your belts, and this is going to be a very easy chapter or section. So number one, we have a little question for you guys. It says, if ON equals 8x minus 6, and I'm going to really encourage you guys, as always, to continue to draw pictures. LN is 5x plus 3. Find the value of x given that LMNO is a parallelogram. Well, they're talking about sides here, and we know from up here that theorem 6.2, opposite sides are congruent. So this is 8x minus 6, and this is 5x plus 3. Well, based off of my properties of parallelograms, I can say, hey, they are equal. or rather congruent. So I'm going to solve for this. My one x is on the same side. Okay. I can do plus 6 to both sides. There we go. Okay. Perfect. And if I plugged it back in, 3 times 8 is 24, minus 6 is 18, 3 times 5 is 15, plus 3 is 18. Boom goes dynamite. Okay? Alright. Basically, all these problems are just kind of revolving around the same idea. Number 2, find the missing variables by using properties of parallelograms. Same idea. They're giving me sides. How do I know that? Well, 1, there's no degrees, okay? And 2, they're just on the outside. So let's start with the y. It looks easier. Just cross them each other. 4y equals 16. Boom, boom. Cross them each other. Divide, divide. Y equals 4. Yay! Do that. I have a parallelogram. Happy dance. Okay? Then, my 5x plus 1 and 6. They are opposite each other. Okay, subtract 1. Alright, divide by 5. X equals 1. Awesome. I wonder if every single parallelogram has that song stuck in their head. I don't know. The things I wonder. Alright, so that's simple enough. Okay, no big deal. Well, let's get to a few problems that involve the angles. Okay, this is a great problem. Hint, hint, nudge, nudge, cough, cough, whatever you want. Maybe make a little note of that. You will probably be seeing it again. I know angles directly next to each other have to add up to 180. But guys, look at this expression. 4y, 3x minus 18, 3z, 2x plus 12. I can't solve an equation that has more than one variable. So I'm going to focus on the x's. They are opposite of each other. If they're opposite of each other, that means they have to be congruent. Okay? So I'm going to start with this. Up top, 3x minus 18 equals 2x plus 12. Alright, let's solve. Subtract 2x over. Plus 18. X equals 30. Alright. I'm now going to plug this back in for both the x's. Down here, 2 times 30 plus 12 gives me 72 degrees. This is for this angle. 3 times 30 minus 18, 72 degrees, because that gives you 90 minus 18, 72. Awesome. Well, now, angles next to it have to add up to 180. Okay? So here's my option. I can say 4y plus 72 equals 180. Subtract 72. 4y equals 108. Y equals 27. And guess I'm doing that here. Same idea. 3z is right next to this one. So 3z plus 72 equals 180. Subtract 72 over. By the way, just a quick note. You see how over here I had 4y equals 108 and right there I have 3z equals 108? That's good news because I know they both have to be congruent to each other. Just a heads up. Divide by 3. Z equals 36. Okay? That's a good problem. It's complicated, but at the same time, all you're doing is utilizing the properties of parallelogram in order to solve. So, please keep that one in the back of your mind. You know, I don't know if maybe you ever see it again. Maybe, like, I don't know, a quiz, test, something like that. But, who knows? You know, I don't know. Maybe. I don't know. Alright, so for the parallelogram below, find the missing variables using properties of exponents. Same idea. Okay. Here I have 70, which is nice. 2x, 8y minus 2. Let's start with the x's. They're right next to the 2x is right next to 70. So 2x plus 70 equals 180. Okay. Subtract 70. 2x equals 110. X equals 55. Now, I have options for 8y minus 2 now, but we see how it's opposite of 70. All I'm going to do is say 8y minus 2 equals 70. I can add 2 over. Divide by 8. Y equals 9. Okay? So, good stuff. And again, same idea. Opposite angles are congruent. Adjacent angles have to 180. Your last little thing for today, if a quadrilateral is a parallelogram, then its diagonals bisect each other. Okay, the key word bisect means to cut something in half. So if I have a line segment and I bisect it, I make two congruent parts. Same. Okay? So look down here. It says for the parallelogram below, find the value of each variable. This is a parallelogram. These are your diagonals. Diagonals are lines that cut through. Okay? So that means that these have to be congruent. All you're doing is saying stuff on the same line have to be equal to each other. So 3x plus 2 has to be equal to 23. Okay, subtract 2, subtract 2. Okay. But then if I look at my y's are on the same line as well. It's being bisected by the diagonal. So I know 7y minus 2 is equal to 5y plus 4. Okay, subtract 5y. Add 2 over. Y equals 3. Alrighty. So, awesome. Quick recap. Okay. Big ideas for parallelograms. Opposite sides are parallel congruent. Opposite angles are congruent. Adjacent angles up to 180. Those are your big blanketing ideas. But meanwhile, to be a little more specific, if you have diagonals for a parallelogram, they bisect one another. Again, this keyword bisect. Okay. All it means is to cut something in half. So if I have a 10-inch line and I bisect it, I have two 5-inch lines, 5-inch, 5-inch. Okay, that's all that bisect means. And again, you could see that in a lot of different spots as well, like carpentry, working construction, things like that. They tend to do stuff along those lines. Alrighty. So feel free to ask any questions. You may grab your homework. As always, good luck. We're all counting on you.